did it. Remember, you're using your calculator. You can't solve, well, probably we do remember logs, but I want you to use your calculator because we didn't do logs yet. All equations start with what? What did I say start with? Y equals what? A times b to the x. Okay? Start with that. Let me just reset this board because I have a funny feeling. Okay, I need all the talking to stop so we can work together here. All right, so the first one. Let's look at the first one. Right in the first part. Assume the bacteria doubles. So, what one do you know? Doubles. Which letter is that? B. Every 3 hours. What does 3 hours have to do? X divided by 3. This is called a cycle. I mean, it's not going to double every hour. It's going to double every 3. So if I have 9 hours divided by 3, I've doubled 3 times. And there are 2,500 present initially. What letter is that? A. So there's your equation. Now, this is doubling. So when you set your window, you're going to start at the zeros because we don't have negative bacteria, we don't have negative time. But your X value probably, I don't know, I'd start with 25. You're looking at hours. This is going to go pretty quickly because it's doubling with a lot to begin with. Make your Y value fairly high. If not, look in your table and see what's happening to that Y if you can't see it on your graph. Okay, so you want a basic sketch. What does this mean over the first 24-hour period? So where do I want to go? Where's my X got to go to? From 0 to 24. So that helps out your X value. Now, your Y value, determine when your bacteria will be 100,000. I need at least 100,000 in there because that's where I'm going to intersect. It's going to be a lot of bacteria. Make it 500,000. Make it 200,000 and see where you see your graph. Go to your table. Look at your table and see when X is 24. What is your Y value? There's your Y max. There's a number of ways you can play with this. You can't do anything wrong to your calculator. If you do, zoom 6 and start again. Sometimes it gets a little confusing and then you'll get a message that says invalid dimension, and sometimes what happens, we change the min, it's the max instead, and it's backwards, and no matter how many times you look at it, you just don't see that part. Just go back and start again. So I want a basic graph, and then we want to know when will it be 100,000. Intersect your line with 100,000. I don't want you solving it with logs yet. We're just doing this exponentially. Good? Make a little bit more sense? Okay. So like I said, the windows are probably the hardest part. But 100,000 kind of tells you, yeah, I need that. And a 24-hour period, let me go see what X of 24, what my Y is equal to. That will help me out. God bless you. Are we good with this? Okay. The next one. Is this the next one? Okay. Again, I'm going to start like this. Let's fill these in. If a population of a town is 123,000, what letter is that?
A.
A. This is A. So far I got this. And it's decreasing at a rate. So where do I put that decreasing at this rate? I'm sorry? B. Okay, we're going to take B. God bless you. And we're going to put what? 1 minus this guy, because I'm decreasing. If I was increasing, I'd be 1 plus. But my population is decreasing. Remember to move your decimal 2 places to the left, and you need the rest of this decimal. So far, this is what we look like. Each year. So is X okay for year? X is good for year. So you got your equation. Always start with this. Easiest way to remember this. Everything pretty much works off of this. Now, I would leave it just like this. This would be me. If you want to, you can subtract. If you don't, take a chance that you might make a mistake and you subtract. Just leave it like that. That works fine. Again, if it's a complete graph and you want all 4 quadrants, you're still never going to be negatives. But you will come from a negative here. But this is not part of our application. So quadrant 1, remember we call it our situational graph. Our complete graph comes from something else. It didn't just start right there. It came from something else. That's your exponential curve. And intersect, what does it want to know? When will it be 500,000? Intersect it with 500,000. This wasn't so bad. So X, go from 0 to 20 right now. Your Y max, what are you going to make your Y max in your window? 123,000. You're decreasing from there, right? You'll never be more than that. So make it 123,000. Make it 150,000. You don't have to be exact. Round it. Give yourself a round number. Make life easy. 200,000 if you like. You need to see it come down and you need to see it intersect. Everybody good with the intersect? Enter, enter, enter. It brings those 2 curves together. Okay. Go ahead. See, determine, that's when you put this in your Y2 and you intersect. So you're going to take this equation in Y1. This is going to be your Y1, and Y2 is going to be 50,000. So you're going to see your population decreasing, and you're going to put 50,000 in there and see where they intersect. Algebraically, you would have to use a log to get this down. So we didn't do that part yet, so right now we're just doing them graphically. And it's good to do them graphically because exponentials, logs are exponents. Logs are just the inverses of exponents. So it shows us that they come from exponential graphs. And were you able to do this one too? Okay, let's start again like this. Half life. Where does the half go? What letter? B. That's my rate. I'm halving this thing. The half-life is 14 days. So if this is my time, what does that 14 days mean to me? It means every 14, there's my cycle. There are 6.58 grams present initially. What letter is that? Is it the Y or the A? A. This is what we started with. Okay. Take it one step at a time. Start with this. Fill in one variable at a time. Write it as a function over time. There's your equation. Draw complete. Remember, it's decreasing. It had to come from somewhere to decrease. But we want the situational part, this part. So we only want this part right here, where it's decreasing. When will there be less than 1 gram? You can do the less than or equal to thing. Well, actually less than. You can do less than, you can set it equal to, and we're rounding anyway. So because we round, we're not going to get that exact. You could say, in terms of days, you could say it's greater than this. It's greater than 39. It has to be a little bit more than that if you round it to the number of days. More than 39 days. Greater than 38.053. We round anyway, so we're not as exact on this. We put the less than here. Set it up afterwards. I don't want that to throw you off, so whatever works out for you there is fine. Questions? So you saw a double, you saw a half, and you saw a percentage. Pretty much you saw all of them. Increases, decreases, doubling, halving. Is that the last one you could do? Go ahead.
How did you find C? Like, how did you solve it?
How did we show this?
How did you solve it?
Solve it? Then you set this to your Y2. Set this at your y2 so you see where they intersect. Right now, all I want you to do is graphically. So y1, y2. And set it equal, because it's less than 1, set it equal to 1. And then you can just say this at the very end. Well, if this is where I'm at 1, then I need to be a little bit more than that to be less than 1, because it's decreasing. So give me just a little bit more time than that. That's how I would set it up. Not worry about the less than 1, because then you don't know what to put in for the y2. You good? Okay. And I think, was that it that you could do? Yeah, that was it. Okay. There's only, what, 5 left? 5 left. All right. What is the value of an initial investment of $2,575 at 8% compounded continuously for 6 years? Some of these you're going to just plug in. Some of them you're going to graph. So how would I start this? Yeah, this is where I'm going to start. Now, because this is one that is money, the A is going to be your initial value. It's going to be this one. It follows the same format. This is my A. This is my B, my rate. I'm increasing. Hopefully, I increase my money instead of decrease it. And this is going to be my time. Okay, it's still the same type of format. So we're going to start with your A. I have an initial value. That's my principal. I'm increasing. Whoops, I'm compounding continuously. Sorry about that. We're compounding continuously. So what do I have to use for continuously? Per. Good. I should have finished reading it first. So per. That's the exception to this. That one runs a little bit differently. Kind of this is like A, this is the B, this is the time. But the natural log has, the natural exponent has its own in here. So we'll just use per. So this will give you the highest return. It's very, very close to the daily, but it's just a little bit higher. So E to the R, how do I write 8% as a decimal? 0.08. Don't forget to turn those into decimals. And how many years? For 6 years. So you can throw this in your calculator and round it. Okay? So some of these you're going to find time. Some of these you're going to find rate. Some of these I don't have, so one I wanted to look at was okay, let's look at this one. Determine an investment of $2,300. It accumulates to a value of $41.50 when the interest rate is 9% and it's compounded quarterly. We need to know how long does it take to reach that time. So we're going to start with your equation. What is your initial investment? What is your rate? 9.09. What's the end? Compounding. 4. Good. So I'm going 4T. That's the part I don't know. Where does this go? 41.50. A. So you're going to do the same thing. You're going to put this in your Y1. You're going to put this in your Y2. Remember, this exponent goes to this piece only. So we can't multiply these guys first. Just put everything, and you would need a log to pull down that exponent. So right now, everything is going into your calculator. When we do logs, we're going to revisit these exact same problems and solve them with logs. And that's your power rule that brings that down. That one's not so bad. So you're going to put these in your calculator. Now, when you do this, you're looking for time. You're looking for time in years. What would your Y max be? what would I set my Y max? If my mins are going to be zeros, what would my Y max be? Bigger than that, right? Just make it 5,000. Make it 5,000. You're making a window. What would you put your X max at? 10, 20. My rule of thumb, go to 20. Because we don't know how long it's going to take, go to 20. What's nice about going a little higher is you get a better curve. You get a better shape of your curve. Sometimes it looks like it's kind of like a straight line for a little bit, but when you go out and you're X a little bit more, you get a better curve. Now you may, I don't have the answer to this, but you may have to go out even a little bit more than 20 if you don't see it intersect.
Mine says invalid dimension.
Invalid dimension is probably your X and Y. Your mins. I don't know what's it. Go to the ninth graders place these calculators all the time. Yeah, change your window. So go to window. No. So if you wanted to take that one off, scroll up to it and hit enter over it. Well, that's what you started with. So you want to, so you're going to end up with 4150. So you want to go to at least 5,000. That's what you started. So you wouldn't be able to see that that was your max. Use your equation to help you get your min and your max. Otherwise, what can you look at? Your table. Start at the zero. You're going to be right there to see what it is. Okay, so everybody's good with those types?
Wait, when you find the intersect, the answer is the Y value?
The answer is your X value.
Oh,
It's your X value. You want to find, it's like a systems of equations. It's really technically like your systems. A one equation, the other equation, substitute one into the other. Set them equal to each other.
It'll be 7 years.
I don't know, what did you guys get?
6.6.
6, give me 3 decimals.
6.6.
So 3 decimals. I don't have the answer to this one. If it says, now here's the difference. It says when, because it's compounding quarterly, it can happen during the year. It can happen during the year. Annually, it's probably only going to happen on a full year. But usually sometimes it will say, if I invested this in 2000, in what year would I reach? Then you're going to have to add those years to that. So say it said I invested this in the year 2000. And you're adding this to it. So it depends how it says it. Same thing with algebra 2. If it says in what year, then I can just add the 6 to this, because sometime during 2006 I will hit that money. If it says at the beginning of what year, then I'm going to have to round this to 7 and go to 2007. Because then I didn't hit it at the beginning of the year. It depends how it's worded. And they word them all differently. Ours is not too tricky. I always found the algebra ones to be a little bit more tricky. They like to throw curveballs at you. There is one that I want to do with you guys. This one is a little tricky. Okay, this. Let's do this. Let's set this up. Determine when an investment doubles in value at 6% compounded continuously. What equation are we using? First. So what should I plug in? The rate. I got a rate. I don't know the time. What do I do? What does doubles mean? Times 2. So think about that for a second. So if I invest $10, how much do I double at? 20. So where could I put in? 2. So if you invested $10, and when you doubled, you made $20. What's A? 20. What's P? 10. Wait, hang on. Okay, so this exponent belongs right here, right? If I invested $200, when I double, what would I be? I would be 400.
So is it
Well, hang on, you gotta use per. You gotta use per. So are either one of these okay? Uh-huh. And if you were solving this, wasn't the first thing you would do is divide both sides by 200? So what is it? Or divide both sides by 10? So what's it going to come down to? 2. I'm just going to put a 1 here for now. Doesn't it come down to 2 to 1 all the time? Don't you double? What if you triple? What would it be? 3 to 1. Okay, so just make life easy, right? 2 to 1. Then you're on a very little screen. You can do your 10-10.
so how do you do?
Same thing. This is going to go into your y1. Because your exponent is your variable, right now we have to graph it. And this is going to go into your y2. And you're going to do an intercept. When we come back from vacation, we're going to do this again with the log statement. And we're going to use your paddle rule to bring down the exponent. Right now, you're going to graph them. So you gotta give me an answer. Oh yeah, I do have an answer. 11 point something. 11.552. Years. Give it a label. So if you set your window to 10 by 10, like a 10, keep your zeros, get your min. If you set it to a 10, would you see them cross yet? No. So if you noticed it, if it's going up like this, and then you don't see it cross yet because you're up here and you can't see it cross, or it's out here and you can't see the line cross because there's the end of your window, that means you're going to have to expand your x value. Your y value is good, but your x value is not. Just rule of thumb, just double your x value. Don't mess with trying to figure out exactly what should my window be. Your window, again, is just the opportunity to look at this graph. So don't sweat the window, just estimate it. You can always break it back down. And again, the higher x, the more you actually see the curve. So give it a little bit of a higher x. All right, there's one that I really do want to do with you guys. I don't know the number of it. This one. I don't have the answer to this quick, but we'll have to work this together. Okay. I'm compounding annually. So my compound formula looks like this. Where does the annual part go? The 1, which becomes 1. N. So let's break this down a little bit smaller. We only need this, right? Agree? If n is 1, let's just get it out of there. Because it's compounded annually, so n is 1. Annually means we're only going to do this once a year. Okay. What's this represent? The initial, but what letter is that? What variable? P. I'm working this one step at a time just so that we can see where these go. Determine the annual interest rate. So what variable am I going to find? R. What's it asking me for? Interest rate. I'm going to find the R. If the value of the investment is $3,000, where does $3,000 go? Which variable? A. After 8 years, where does 8 go? T. Okay, now remember, This exponent goes with this. That's the guy I need to find. So I want you to put this in your y1. I want you to put this in your y2. See if you can find an intersect for me. It'll take me that long to get it in my calculator. Anybody come up with an answer? Somebody give me their windows so I can put it in mine. So the mints are at zeros, right? The mints are at zeros. We can't have negative money or negative time. What's your X max? 1. Why would you say 1?
Because the rate's gonna vary.
Ah, so very good. But can I put 10 here for a minute?
Yeah.
Thank you. So we're going to put 10 because I'm not thinking rate like Ashley is thinking. Very good thinking. What is my Y max? We should be able to hit the Y max. What's the Y max? Okay, 5,000 because you need to make 3,000. So make it higher. You're only giving me a window. So I'm going to take Gabby's 5,000 and I'm going to graph this. Maybe. And I don't know what happened to my graph. I got it there. Now watch this. I'm going to do an intersect. I don't know what happened to my graph. I hit it once, twice, and I guess again. Get this interest rate. Look where your graph is. Your graph is sitting right here on this axis. Because Ashley said, if I can get back to my window. Ashley said X should be maximum of 1. That's your rate. Isn't your rate a decimal? Even 1, that's 100%, right? So would you get a 100% return? Never in a million years, but we can set it to 1. You got to consider what is your X value. And that's small, but we can do an intersect. You could do an intersect before. Even though you couldn't see the graph was there. The graph was sitting real close to that x-axis, to the y-axis. If you look at your table, this will give it away. What does this mean, e to the 8? Zeros. Oops, wait, I'm in the negative, sorry. Let's go down here. So again, I'm making a lot of money here, but what do these tell me? Whoa, I'm way out of this. Where's my 3,000? I don't even see how they went to 3,000. Here's my initial value. This is 404 million. Where's my 3,000 fall? Really small. Isn't it falling between 0 and 1? Right? Somewhere really close to the 0. If I look at my table and these E's, it says move my decimal place 8 places. That's absurd. All I want to do is find 3,000. My 3,000 fell right in between these two numbers. So remember, set your X close to that. Set your X close to that. And you'll see it. You can even set your X, if you wanted to, 0.5. Chances are nobody's going to give you 50% return on your money, right? Maybe it's just a little bit wider that way. But you can still, it's still out there. It's still there. What does the 2 represent? 2 is my rate. That represents 200%. 3 represents 300%. That's why those numbers were so huge. Wouldn't that be nice if a bank would give us 300% interest?
So is the answer,
What did we get? 0.08 something? What was the 0.0 what? And if I turn this to a percent, this is 8.3%. This is my rate. I wanted to do the rate with you because if you don't catch the rate and you're going to spend a lot of time looking for something that is still there, but you just couldn't see it because it was so close to the y-axis, it was so small. Okay? So if you guys finish this one,